Pairs of angles. This is lesson 3. Your learning targets are to be able to identify adjacent vertical, complementary, and supplementary angles. You'll also be able to find measures of pairs of angles. Your vocabulary for this lesson are adjacent angles, linear pair, complementary angles, supplementary angles, vertical angles. Angle relationships. Many pairs of angles have special relationships. Sometimes it's because the measurements of the pair. Sometimes it's because the position, where they are located in conjunction with each other. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. Angles 1 and 2 are adjacent angles. You can think of adjacent angles as they share a wall or the center ray. A linear pair is also a pair of adjacent angles. The difference is that the uncommon side are opposite rays, and so they form a line. So these are next door neighbors still, but they're on the same street. An example would be identifying. We want to find out, are the angles here adjacent and form a linear pair, or not adjacent? So we're looking at angles AEB and BED. We can see that they have a common point, and that's the vertex E for each of them. AEB and BED share a wall, so they are adjacent. But not only that, their non-common side forms a line. So these are not only adjacent angles, but they also are a linear pair. Now let's look at AEB and BEC. So here's AEB, and we want BEC. Okay. We can see that they still share the same vertex, which is E. They have a wall that they share, so they are neighbors. But it's like they're around the corner neighbors, because EC is not an opposite ray to AE. So they are just adjacent, but not a linear pair. If we look at angle DEC and AEB, we see that they do share a common vertex, but they don't share any walls. There's a house between them, so to speak. BEC is between them. Therefore, they are not adjacent angles. Once again, we're looking at adjacent angles, linear pairs, but this is a little more complicated. So let's look at this. We want to look at angles 5 and 6. Well, if we look, angle 5 is really angle TPU, and angle 6 is UPQ. And we see that PQ and PT are opposite rays. These share a wall, so they are adjacent angles. But their non-common side makes a line, so they're actually on the same street. They are also a linear pair. So you try. Tell whether the angles are only adjacent and form a linear pair, or not adjacent. We're looking at angle 7 and angle SPU. Did you say that they are not adjacent angles? They have a common vertex. They don't have a common side. In fact, angle 7 is contained in SPU. Let's try another one. We're looking at angles 7 and 8 this time. Take a moment. Did you decide that these also are not adjacent angles? Angle 8 is on the left. Angle right is on this side here, on the right, on the left. And I said that backwards. Angle 8 is on the left, angle 7 is on the right, and angle RPS is between them. These are not adjacent angles because they don't share a common side. Let's look at relationships in measurement. A complementary set of angles are two angles whose measures have a sum of 90 degrees. In other words, they add up to being 90 degrees. Supplementary angles are two angles whose measures have a sum of 180 degrees. Many adjacent angles are complementary angles. All linear pairs are supplementary angles. You can find the complement of an angle that measures x degrees by subtracting its measure from 90. So anytime that you're looking for a complement, you will use 90 minus x degrees, whatever measurement you're given for an angle that you want to find its complement. You can find the supplement of an angle that measures x degrees by subtracting its measure from 180. So any problem that asks for the supplement, you're going to use 180. Complement, 90, supplement, 180. Let's look at finding the measure of complements and supplements. Example A here, we want to find the complement of angle F. Angle F is 59 degrees. So we subtract 59 degrees from 90 and we get 31. We want the supplement of G. G is 7x plus 10. We will subtract 7x plus 10 from 180 degrees. We end up with 170 minus 7x degrees. Now you try. Find the measure of each of the following. We want the complement of angle E. Did you work it out by subtracting 7x minus 12 from 90 degrees? You should have gotten 102 minus 7x degrees. Let's find the supplement of F. And F is 116.5 degrees. Did you get 63.5 degrees? If so, you are correct. We can use complements and supplements to solve problems as well. An angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. Step 1. Let's let measure of angle A equal x. Then B is its complement, and that measures 90 minus x degrees. We're going to write and solve an equation. X equals 3 times the measure of the complement. Since B is 90 minus x, we simply multiply by 3. We use the distributive property. And we get that x is 270 minus 3x plus 10. Simplifying, just combining the like terms, we get 280 minus 3x. We can solve for x by moving the negative 3x to the other side. We have 4x equals 280. Dividing by 4, we end up that x equals 70. And then we use a complete sentence to describe the answer. The measure of the complement, b, is 90 minus 70, which equals 20 degrees. An angle's measure is 12 degrees more than the measure of its supplement, 1/2 the measure of its supplement. Find the measure of the angle. We have to make some sort of equation. X equals 12 degrees more than 1/2 the supplement. The supplement is going to be 180 minus x, so we substitute those into our equation. We use the distributive property. Combine like terms. Divide both sides by 1.5. And simplify. X equals 68. So the measure of the angle is 68 degrees. This is a little bit more complicated problem. Light passing through a fiber optic cable reflects off the walls of the cable in such a way that the measure of angle 1 is congruent to angle 2. Angle 1 and 3 are complementary, and 2 and 4 are also complementary. If the measure of angle 1 is 47 degrees, we want to find the measure of angle 2, 3, and 4. So first of all, we need to understand the problem. The answers are angles 2, 3, and 4. So we're going to list what we know. Angle 1 and 2 are congruent. 1 and 3 are complementary. That means that this forms a 90-degree angle. And 2 and 4 are also complementary, which forms a 90-degree angle. And we were told that the measure of angle 1 is 47 degrees. We're going to make a plan. If 1 and 2 are congruent, then the measure of angle 1 is equal to the measure of angle 2. So that would be 47 degrees. If 3 and 1 are complementary, then their measures equal 90. So the measure of angle 3 is 90 minus 47. Since 1 and 2 are both 47, then the measure of angle 4 is also 90 minus 47 degrees. Then we solve. By the transitive property, if measure of angle 1 is 47, then so is angle 2. And both angles 3 and 4 are 43 degrees. If we look back, we find the answer makes sense, because 47 and 43 equal 90 degrees, so that 1 and 3 are complementary, and 2 and 4 are also complementary. But what if we changed and the measure of angle 3 is 27.6? Go ahead and find the measures of angle 1 and 2 and 4. Make sure you finish your notes, write a summary, and I'll see you in class next time.